Hey class, this is Miss Wesley. Here I am on your computer screen using a new program to record these videos now. So you're going to have to just forgive me for if I'm fumbling with the features of it. But I think it just make the video a little bit clearer, a little bit easier to understand. And I hope you're excited to get into our third day working with u-Substitution. Each day we've kind of added a new type of question to the mix. And we're starting to get into ones where it's a little less obvious what U is going to be. So we'll still continue to talk about strategies for picking U and so forth and so on. We're on page 5 of the packet. This is a page we were on last week already. So as you turn there, you're going to notice you have filled in work already for 1, 2, 4, and I think a couple others. But I don't think 3 is one of the ones that we've done yet. So I want to start with the ones that we haven't looked at, like number 3. Okay, so here's the fun part. I'm going to try to get a marker here and see if we can write out. We want to make a U choice for number 3. So we'll say let U equal. And think about what you would make U here. I don't think you have much of a choice. When you have a constant up top, there's not even an X up there to really pick to let U be that. And the question is, what do you want to make it? The entire bottom with the power or just the inside? And I'm hoping you're thinking just the inside, the innermost part of this function that's being raised to the third power, the 1 plus 2x. And then we continue with the side work, right? We take a derivative next, so du dx equals what? I guess just the number 2. And then this always gets solved for dx, so du equals 2 dx. And I think the side work is all set. I'm going to switch to a blue pen as we go back to the original function and sub back in to make this look a little bit simpler. So the 4 stays. On the bottom, what are you going to write? We're going to write u to the third. And then in for dx, what are we going to write? Well, I guess I didn't finish solving for dx down here. And this part, I guess you could have done in your head. But it's going to be du over 2. So this we'll use, and that we used. So du over 2 is a good thing to plug in for dx. And you might want to simplify before you take an integral. 2 goes into 4 twice. So we're integrating to u to the negative third du. Easier integral to take. I think we're through the toughest part of this question. Not so bad. So let's drop the integral sign. We'll leave the constant. Make it 2 times 1 over 1 higher than negative 3. So negative 2 u to the negative 2 plus c. Indefinite integral. And this whole thing's negative 1. And for u, we could write exactly what we set u equal to. So 1 plus 2x, and to the negative second power, and then plus c. Now this is a little risky and probably silly of me. I can put a circle or a cloud around my answer. Let's try it. It didn't work out very well. I'm gonna just get, oh man, okay, should have quit while I was behind. Let me, oh, it just went away. Let me try the old circle. Let's see if this works. This will probably be like 2 rounds of it. Oh, well that was a success. It's life's little successes like that I think we need to hold on to. I think we can scroll now. So I'm back to a marker, and I believe that 5 is the next one that we haven't filled in yet. So 5's a good, oh, this is a great one with the fraction there. So we look at it, we know there's some sort of need for some substitution. So we're going to let u equal something. So we've got some choices here. X cubed is a choice. This bottom is a choice, but we never really do the whole thing with the power, so I would think just the inside of those parentheses would be our choice. Can you find something that's either more complex, more inner, or whose derivative appears? And I think this is going to be our option. It's more complex because it's to a higher power. Its derivative doesn't appear, but the power of its derivative appears, so that's helpful. And it definitely is more inner than the x cubed because it's inside of parentheses raised to the 1/3. So let's use the inside of that denominator, and we'll take a derivative. Okay, derivative, 1's derivative is nothing. And then the derivative of x to the 4th, 4x to the 3rd. Du equals 4x to the 3rd. We'll multiply the dx over. And then this time I won't forget to solve for dx. Man, I was really shaky with this handwriting at first. I think my handwriting got a tiny bit better on this one, but I still have a way to go. Let me switch to blue. Or let me switch to green. How about? Let's see how we like green. And we're going to use both of these circled items plugged back into the original. We want to integrate x to the third. We're hoping that goes away in a future step over u to the 1/3 power. It's a little bit sloppy there. And then dx, we'll write du over 4x to the third. And this is where we pause, take a step back, and make sure that the x cubes are going to cancel, because if all the x don't cancel, we either made the wrong u choice or we got to do something else. And they should. X cubed up top, that look good. X cubed up top, and x cubed on the bottom. And now you're integrating. The 4's on the bottom. We can write a constant of 1/4. And then u, let's swing the variable up to the top, u to the negative 1/3 du. Now's the time to integrate. We leave the constant. Is it just me, or is this getting like a little bit fun? Am I crazy here? U to 1 power higher, so 1 plus negative 1/3 is going to be 2/3. So we will divide by 2/3 as long as we raise it, to the 2/3 power, because we're going to multiply by the reciprocal of 2/3, which is going to be 3/2. And then the plus c needs to go in the answer once you've integrated. So we'll see how that looks and sub back in for u. This is 3 over 4 times 2, so 3/8. U is 1 plus x to the 4th, 2/3, and then plus c. And then I'll try my luck at that circle, or maybe we'll box this solution. How about? No, I want to do this circle. I like this circle better. And kind of missed the 2/3 there, but you can't win them all. 6 is the next one. Did you know this is kind of cool? I can move myself around the screen. So, I'm up to the right. I'm over to the left, right? Okay, so I'll just put myself, how about right up here? And I'll join you from up above. Okay, let's look at number 6. If you want to pause the video now and try number 6 on your own, that might be a good idea, because I think you guys have this one. I think you're going to know what you should be, and I think it's an easy plug back in. So I'll rejoin you so that we can check the solution. And I first want to pick what u should be, right? So we said let u equal, do you see an innermost part of this function? And I think it's the power that we're raising e to, 5x plus 2. Du dx, derivative of this should just be 5. We will multiply the dx over 5 dx and solve for dx. Du over 5 equals dx. Not so bad, huh? And switch to black. And we'll go back to the original integral and plug some of this stuff back in. E to the what? E to the u. And for dx, du over 5. And now this will be easier to integrate. 5 on the bottom means a constant of 1/5. E to the u, du. And e to the u, probably one of our favorite things to integrate because it doesn't change. It stays e to the u. And the plus c because it's an indefinite integral. So 1/5 e to the 5x plus 2 plus c. So we're ripping right through these. And you know what? I'm just trying to draw that circle on my own. Out of the last two, we've already looked at 7 together, so I think we should look at 8. Let's take a look. It says x sine of x squared. Okay, so we have a few more options here for our u choice. This is one of those less obvious choices for u. So I'll put the let u equal first. All right, so let u equal. Now we brainstorm as a class. What are our choices? Our choices are x, but I think that's just silly because if you made u x, you wouldn't have changed the original much at all or made it any simpler. Maybe it's x squared, or maybe it's sine of x squared. Out of these two, it's hard to compare them in terms of one being more complex. You can't say one's derivative appears, but you can say the x squared is more inner than the sine of x squared. So I think our winner is x squared, kind of like we made it 3x in number 7 because that was the inside, and we'll take a derivative. I want to repeat myself too. If this part is the hard part, making the choice of u is the tough part, and if we mix it up and choose the wrong thing at first, we will know very quickly that we made the wrong choice when we plug back in and all the x's don't cancel. So let's try that and see if they do cancel. We're going to take a derivative. du dx equals 2x. Du equals 2x dx, if you multiply the dx over, and we'll solve for dx. Du over 2x equals dx. Okay, so I'm feeling good about this because I look back up at the original, and this. And we'll go green and go back to the problem, and can you sub stuff back in? At first, the x stays. We don't have anything for that yet. We're just hoping it goes away. We can write sine of, I can hear Soldier Boy right now. He's saying u, sine of u, right? Because x squared is what we called u. And then in for dx, we can put du over 2. I got that from the bottom of the page. Oh, over 2x, how about? And that is good news that that's a 2x there, because you needed the x's to cancel. This whole thing needs to be in terms of u. And I think that just made it happen. So we will integrate. Let's just clean this up a little bit. Integrate 1/2, because I see a 2 in the bottom of the fraction, sine of u du. The 1/2 stays. What is the integral of sine of u? We'll say cosine of u, and it's negative because, right, the derivative of negative cosine would be positive sine. So negative cosine goes there, plus c needs to be there eventually, and our final answer needs to be all in terms of x. So what was u again? U is x squared. So cosine, I'll put of x squared and then plus c, and that one's all set. Those are the practice ones I wanted to try. Since we finished a little early, we have a little extra time, your homework's gonna be the next page, and I wanted to look at one of them with you, kind of just get one of the homework questions out of the way. So flip over to page 6, it's got a ladybug at the top, and then I thought the toughest one on the page, or the one that would be best to talk about, would be number 5, and I think that maybe we can just start it together so it's a little bit easier when you're brainstorming on your own. Okay, 5 is crazy actually. Let me circle it and star it. And you got to make a u choice. I don't think it's going to be x. And it might be ln of x squared, or it might just be ln of x. That's what I'm leaning towards. Let u equal ln of x. I pick it because it's a little bit more complex than x is, and it's more inner than x would be too, because it's inside of parentheses raised to the 2nd power. Now it's been a minute since we have taken the derivative of ln. It's du dx. Remember the derivative of the natural log? It was 1 over x. Okay. Then we're going to cross multiply, so we'll make it x du. And guys, here's a joke. Have you heard about the biggest concert that everybody's heading to this summer? It's the XDU concert. Get it? Like the country station XTU, but this is like an integral concert. Okay, I'm just going to stop. Okay, so then this is equals dx. And now I think this is going to work. I think we have enough to take back up into the original problem and make it simpler. You want to integrate ln of x, so we called that u squared, right? Over x for now. And I didn't finish this side work. We want to, well, we did solve for dx, so I did kind of finish it, but this is what we want to plug in for dx, x du. We got this by cross multiplying that derivative. So x du gets plugged in for dx, which is very exciting news, making the x's cancel. So bam, bam, and we're just integrating u squared. So we made kind of a crazy problem into a very simple integral, right? 1/3 u to the 3rd plus c, and we can plug back in for u. 1/3, what was u again? ln of x. 1/3 ln of x to the 3rd. Those parentheses are necessary. They are crucial, so everyone knows what you're cubing. And then plus c, of course, because how could we ever forget the plus c? You guys deserve another pat on the back. We got one of the homework questions out of the way. I hope that you're enjoying your day, and I will see you next time. Okay, bye.